Today we will learn about principal and interest on loans as a way of understanding exponential functions. Suppose we borrow $100,000 from the bank to start a company, with the plan to pay it back in 1 year. How much will we have to pay back? $100,000? But then what's in it for the bank? We have to pay back more than what we borrowed. The percent more is called the annual interest rate. If the bank charges us a 10% interest rate, then how much do we have to pay the bank in 1 year? Well, we have to pay them back the $100,000 we borrowed, plus an additional 10% of the $100,000. We can write 10% as 0.1. This comes to $100,000 plus $10,000 in interest, for a total of $110,000. So we owe the bank $110,000 1 year after borrowing the $100,000. Now suppose the bank allows us to borrow the money for a second year, as long as we still pay the 10% interest rate. How much will we owe after 2 years? Well, we owe the $110,000 we owed at the end of the first year, plus 10% of that $110,000 for the next year's interest, which is an additional $11,000. So we owe them a total of $121,000 after 2 years, which comes to a total of $121,000. So we owe the bank $121,000 after borrowing $100,000 for 2 years. Notice we paid $11,000 rather than $10,000 in interest the second year, because we paid interest on the original $100,000 as well as we paid interest on the $10,000 from year one's interest. Paying interest on interest is called compound interest. How much will we owe if we borrow $100,000 for 3 years with an annual interest rate of 10%? Well, we know we owe $121,000 after 2 years, plus an additional 10% on the $121,000 for interest in the third year, for a total of $133,100. Notice that the amount of money we owe is a function of how long we borrow it for. The amount of money we owe is called the principal. We write the function p of t as the amount of money owed, principal, after t years, and t is the number of years the money is borrowed. In our example, so far we found that p of 0 is $100,000. That is, the moment we took the loan out, we were going to have to pay back the $100,000. To find p of 1, the amount we owed after 1 year, we had the $100,000 plus 10% of that $100,000 in interest. Notice that we can factor out the $100,000, and we're left with $100,000 times 1.1. for a total of $110,000. To find p of 2, we started the second year owing $110,000, that was p of 1, plus 10% on that $110,000. Here, we can factor out $110,000. When we do this, we're left with $110,000 times 1.1. But recall that the $110,000 we could write as $100,000 times 1.1. So we're left with $100,000 times 1.1 times 1.1. Or in other words, $100,000 times 1.1 squared, for a total of $121,000. After 3 years, we owed $121,000 to start the third year, which is p of 2, plus 10% of the $121,000. Again, we can factor out. This time we factor out $121,000 to get $121,000 times 1.1. But we can rewrite $121,000 as $100,000 times 1.1 squared. In total, we have $100,000 times 1.1 cubed, which comes to $133,100. Let's look at the pattern we found. P of 0 was $100,000. P of 1 was $100,000 times 1.1. P of 2 was $100,000 times 1.1 squared. P of 3, $100,000 times 1.1 cubed. The pattern becomes even more apparent when we write 1.1 as 1.1 to the first power. And if we write $100,000 as 100,000 times 1.1 to the 0. Remember, if we raise any number to the 0 power, we just get 1. Looking at this pattern, can we figure out what P of t is for any time t? P of t is $100,000 times 1.1 to the t, where t is the number of years we borrow the money. With the equation P of t equals $100,000 times 1.1 to the t, let's remember where the 1.1 came from. The 1.1 came from 1 plus our interest rate of 0.1, or 10%. In general, if we borrow P naught, or P of 0, dollars for t years with an annual interest rate of r, then the amount we owe is P naught times 1 plus r to the t.